this episode, we would like to say that in the spirit of reconciliation, that we acknowledge the traditional custodians of country throughout Australia and their connections to the land, sea and community. Welcome back to another episode of Spaghettification. My name is Mark Iscaro and I'm the Drunk Astronomer, and we have Stephi with us.
Hi, my name's Stephi Bernard. I'm AstroSteph. We're here with Aman Chokshi. Aman is a PhD student in radio astronomy at the University of Melbourne and the ARC Centre of Excellence for All Sky Astrophysics in 3D, Astro 3D. Over the last several months, he's been working at the South Pole in Antarctica at the South Pole Telescope. As well as being an astrophysicist, Aman is also a talented astrophotographer who's been taking advantage of the winter skies in the Antarctic. Welcome, Aman.
Thank you, Steffi and Mark.
So our first question for you, Aman. So tell us a bit about your research into the Epoch of Recombination. What sort of time in the universe are you looking at?
So we're basically looking at one of this, I guess I'd call it the second important epoch in the history of the universe. So we had the cosmic microwave background, or the Epoch of Recombination, which happened first. And it's when the plasma soup, this hot plasma soup of the early universe, kind of cooled down and expanded sufficiently to combine into neutral atoms. And at that point, the universe became dark and continued to expand. But this matter, there were density perturbations in this matter, and they coalesced gradually through gravity. And as they collapsed onto themselves, they grew warmer and warmer. And as they grew warmer, they started to glow and get hot, and you had the first galactic clusters, galaxies form, and the first stars light up. And that is the epoch of reionization, where these first luminous sources in our universe produce energetic UV radiation, which goes and breaks up atoms again. And so we go from a neutral universe back to an ionized universe, which is what we currently are in. And we don't actually well know what we like, the morphology and the transformation from this neutral to ionized. And that's kind of core goal of what people who are studying Epoch of Reionization are trying to understand. And as part of my work, I work with the radio telescope in Western Australia, the Murchison Whitefield array. And it's a very interesting telescope. It looks like a bunch of spiders spread out across the Western Australian desert, like 3 square kilometers of it. And but it's a very unique instrument. So it's low frequency. It looks at a huge bit of the sky. It's a challenging instrument to work with, but it's really amazing what it can do.
So when you're talking about radio astronomy, what makes that a bit different from what we might think about with, the regular telescopes that we have all become familiar with?
Optical telescopes and I guess Hubble are a very important part of the perception of astronomy and astrophysics. You see beautiful, colorful images of the night sky. And oftentimes these telescopes are looking at much more local picture of the universe. We're looking relatively nearby for the scales we're talking about on a cosmic scale. And radio telescopes can probe much further into the history of the universe. And yeah, you often don't get pretty images. Well, it's possible, but quite often you don't. You're looking at plots and power spectrum and more statistical analysis to tell us what's going on out there. But there are also a lot of advantages. We're not as obscured by the local universe, so we are situated within the Milky Way, and everything we see is through the haze of the foreground of the Milky Way sky. Though beautiful, we're not actually trying to observe that when we looking at distant objects or distant light. And radio wavelengths are long enough that the dust in the Milky Way is basically invisible to them. So the wavelength just curves around this dust, and we can see through all of it, or a lot of it. And so we have different foregrounds, but there are advantages.
I mean, that's amazing to me as a optical infrared astronomer, that you can look through the Milky Way and actually still see stuff behind the Milky Way. Like, if I looked at the Milky Way, I would just be absolutely, it would be beautiful, but everything would be covered. I wouldn't be able to see anything further than, the nearby sort of stars that we look at. So that is amazing. I didn't actually know that.
I actually have a question related to that because, as our listeners would know, I'm the 5-year-old drunk astronomer. So I like to ask lots of silly questions, and I want to know if there's a difference between, say, the dish at Parkes and the Whitefield array. What the difference between those two is, and is there a difference in how they record data?
There is a difference in how they record data, but there's also like a more fundamental difference on how they see the sky. So the dish is basically a very big lens, and you can think of it as a very big zoom lens. So the bigger the dish, the narrower the bit of the sky you see, and the more fine detail in that small bit of sky you see. So Parkes, I think it's a 64-meter dish or something like that.
Yeah, it's 64 meters, yeah.
And so it sees a tiny bit of sky in incredible detail. And as you go smaller in dish size or antenna size, you're seeing a wider bit of the sky. So the way you guys should look up a picture of the Murchison Whitefield array. I'm sure Steffi knows what it looks like, but it's basically, we have, we call them bow tie dipole antennas, which are basically a cross, like two antennas in a cross, and they're basically like this big, like less than a meter. They're 80 centimeters square, and we arrange those in a grid of 4x4 antennas, and we call that a station or a tile. And each tile can see, like the central part of the frequency band we look at can see 25 degrees in the sky. So 25 by 25 degrees square in the sky. And that is a gigantic piece of sky you're looking at compared to any optical or any radio telescope, or most radio telescopes.
So just to compare, the full moon is about a quarter of a square degree, and so you're looking at 25 whole square degrees. So it's a very big patch of sky.
The really interesting thing is that about interferometer. So the telescope, the MWA is an interferometer, which basically says it takes multiple smaller telescopes, which could operate by themselves, and combines them to get better resolution. So each of these tiles can see 25 square degrees, and we have 128 tiles spread across 3 square kilometers of desert. And what we do is basically correlate the signal observed by 2 tiles by every single pair of 2 tiles. So they're like 8,000 pairs of tiles. What we're doing is we kind of say they're both looking at the same patch of sky, but because they're located not at the same position, slightly far away, they see slightly different things. And this difference in signal tells us a lot. And the further away the two baselines are, or the ends of the baselines are, the more resolution or the finer detail on the sky you can see. The end result of a telescope such as the MWA is that you can look at a wide piece of sky, so 25 square degrees, but have the resolution of a telescope 3 kilometers in diameter. And so that's like a fantastic thing.
It's just amazing. Like I've
Very
heard,
cool.
I've heard about the MWA for a long time, since it's been being built in WA, but hearing all those details is like, oh yeah, this is amazing.
And the really cool thing is a lot of the hardware in the actual antennas is very, very basic. It's something you could technically build in your garage, and all the science that happens is mostly software related. So it's like a software driven telescope as opposed to a extremely complex hardware driven telescope.
I'm curious to know how someone who's working at the South Pole gets into astronomy. Like, what was there something that happened in your youth that got you to where you are right now?
Definitely. So both my parents were scientists, and my mom was an astronomer. And
Oh, really?
yeah, yeah. And so she stopped astronomy and went into other stuff when I was like close to 10, I think. Actually, close to 5. Yeah, but that didn't stop it. So we at home we got cool pictures from NASA. We went out for meteor showers, that kind of stuff. So that was like really early stuff, and then kind of got lost. And then I think I was doing my undergrad in physics, and I went out to the Himalayas just by myself for a couple of months. I was like high altitude deserts and like saw the stunning view of the Milky Way. It was at that point that I was first trying out astrophotography and like just pointing my camera and see what I got, and I was like blown away. And I was like, oh, this would be really cool to study. And I guess that's how it happened. It just like, oh, I should do this. And then I applied for what's it called? Not an outreach internship. I applied for an internship at a astrophysics center in India and did a bit of radio astronomy. I knew nothing then, and people were really nice, and they were like, here are the basics, and come help us hold this antenna up, and like this is cool. And it just went from there.
So I guess the next question sort of follows on from that. So what came first, wanting to do astrophysics or astrophotography, or are they sort of interlinked for you?
For me, they're definitely very, very interlinked. Yeah, it's like each time I go outside or I'm at a place with dark skies, I'm like it just blows my mind. Like it's so amazing. Any chance I get, I try and get away from city lights and be somewhere dark and camp out or shoot the night sky. And that's a big part of why I'm doing what I'm doing. And it's like you go out there and you wonder what's out there, how did it come to be, and it's just beautiful. So they're very, very intertwined for me.
You're currently down at the South Pole, at the South Pole Telescope. How the heck did you get there? Like, why did you want to work at the South Pole, and what was it like actually getting that gig? Like, how does someone get a job working down at the South Pole?
Okay, so it's kind of a weird story. So I got to Melbourne a couple of years ago and met a professor who Steffi knows at the University of Melbourne, Christian, and he was like, oh, my whole team works at the South Pole. We work with the South Pole Telescope. I was like, that's so cool. Can I go there? And he was like, sure, in principle, people do go there. And then I completely forgot about it. And it was, I think, like 2.5 years later that he sent around the email that people are looking for candidates to work at the South Pole Telescope. I was like, man, I've been in lockdown in Melbourne for 2 years. I haven't seen anyone. I've been living with my housemates. It's not that great. South Pole can't be worse. It'll be an adventure. So in the winter down here, there are 44 people this year, but it's usually around 40 to 45 people. And in the summer, we have 80 to 150 people. And so I just applied for the position and had many interviews, a whole bunch of medical tests, got my wisdom teeth yanked out. And yeah, it worked out. But there are a lot of positions down here. Like, I think this is an American station. And so most jobs other than science are only open to Americans. But the science and research that goes on are through universities, and they hire internationally. But there are a bunch of stations, like a lot of countries have, like Australia has 2 countries. So anyone who's interested in being down here, it's a amazing place to be. You should just Google research stations in Antarctica and find the one closest to your country. And there are a bunch of interesting jobs out there.
So I know.
I need to come back to the wisdom teeth thing.
Yeah.
Why did you have to have your wisdom teeth out?
So they do really comprehensive test. It's called the PQ process, a physical qualification process, and they basically need to ensure that nothing is going to go wrong with you down here. And like in the old days, I think you had to, like some people had to get their appendices removed, but that's not the case anymore. We have 2 doctors down here for the winter with us, but essentially there's no chance of medical aid, external medical aid during the 9 months of isolation down here. And teeth problem are common. So if your wisdom teeth are in a state where they might cause problems, they're like, out with them.
That makes sense. So it's like a preemptive strike, I guess, of making sure that
Yep.
anything that can go wrong is removed from the situation.
Basically, yep.
Yeah.
So
Very cool. Wow. What an excuse to have your teeth out.
It's great.
Sitting in a dentist's
I would
chair.
have
So
put
why are
it
you
out
having your
for
wisdom teeth
ages.
removed? I'm going to the South Pole.
Oh, I have a super cool story about that. So it was lockdown, and I had to find a dentist who would yank out all my teeth. And there was one right next door to me in Carlton. So I knocked on that door and said, I'm going to the South Pole. Will you please yank out my teeth? And they're like, sure. Let's do this. And so I'm there for the appointment, and this guy is a huge Iranian dude. He's like 6'6". He comes in a jacket and a bowler hat with feathers in it. I was like, what a character. And
that's amazing.
so I thought I was going to be knocked out and they were just going to yank them out and a friend was going to pick me up and take me home. He was like, no, we'll do it on local anesthetic. It's like, are you sure? He was like, yep. And in the middle of this, they were struggling and trying to get the teeth out. And he was like, do you know who has the same birthday as you? And he was like, Osama bin Laden. I was like, what? Why would you tell me that?
Oh my gosh. Oh dear.
He was like,
Yeah.
he was looking at my documents just before he got in, and he's like, oh. So that was a fun story.
Yeah.
So Osama bin Laden's currently down at the South Pole Station then, according to that dentist.
Who knows? Could be.
So I haven't been lucky enough to go to Antarctica, but I have been lucky enough to fly over the coast, and we flew down to the McMurdo station and Mount Erebus. So what was it like sort of leaving Melbourne to go to the South Pole? How did that feel?
It was horrible. It was the longest journey. So I had to fly from Melbourne to San Francisco, spend 3.5 weeks quarantining there, and then fly to New Zealand, quarantine for another 2 weeks there, and then fly to McMurdo. I was like, hey guys, can't I just fly to New Zealand? It was like, let's think about it. No, you gotta fly to San Francisco. And but then you get off on the ice and it's like, whoa, this is real. You just landed on a runway made of sea ice and you're at McMurdo and you see a volcano spewing like fumes right next door. And then it was amazing getting there finally, but the journey was not that fun.
Did they give a reason why you had to go via was it San Francisco?
San Francisco. Yep. So basically, it's the U.S. National Science Foundation bunches group together in what they call cohorts, which fly down together. And once they form a cohort, they're isolated from anyone else to prevent COVID and stuff like that. And they were like, we can only ensure, or we can only guarantee your safety if you're with the cohort from the beginning. So you have to enter. And then they were like, CDC or whatever the US has said, if you're entering US, you need to be there at least 2 weeks ahead of the time you entered the cohort. So
Okay, yeah, that makes sense now.
So once you got to McMurdo, how do you get, because that's sort of near the coast, how do you get to the South Pole in the interior?
well, so we had to spend, I think, a week in McMurdo, just again, isolation step to say if COVID somehow got to McMurdo, prevented from getting to the South Pole. And once you finish that time in McMurdo, which was actually very cool because we got to wander around, see seals, and go on hikes. Weather, when the weather permits, we fly in Dazzlers, or I think they're DC-3s or DC-10s, so airplanes from World War II, like literally World War II, and we get on them, and yeah, it's a small plane. On the way up, because there's a huge elevation gain from sea level to 100,000 feet, not 100,000, sorry, 10,000 feet. On the way up, they can take the pilots and 14 people, and on the way back, they can only take, I think, up to 6 people because they're taking off from such a high elevation. So we got packed into a Dazzler, and it's a 5-hour flight over the Transantarctic Mountains and then the Antarctic Plateau. And it was clear, and so we got an amazing view of the mountains.
Yeah, I bet. Oh my gosh, yeah. One of the things that when I did this flight from Melbourne over the coast was just how many different sorts of, I guess, landscapes there are in Antarctica. Like you sort of expect like just white sort of ice, but there's like valleys, there's glaciers, there's the ice, there's all sorts of things. I'm sure you got to see all of that.
It's amazing. It's like you go these sharp mountain ranges and like rivers of ice, and then you're passing through like a gap between 2 mountain ranges or sub-mountain ranges, and you see this huge ice sheet, and then you look down and it's like aqua blue crevasses all over, and it's just like it's like completely full of crevasses.
You are currently at work, so what can we see in the background behind you? You said that there is some real science going on.
Yeah, we want to know about the science.
So we're currently in the B2 science lab, where all the science experiments kind of operate from. There's nothing much to see here. The telescope is actually 1 kilometer out. So we can do most of the controlling of the telescope from here, but we do go over to the telescope at least once a day to check on things. Yeah, so the telescope is a cosmic microwave background telescope. So it's studying the first light that's possible to see from after the Big Bang. So I talked about the epoch of recombination, when I guess protons and neutrons and this plasma from the early universe just combined as the universe got cool enough to form neutral atoms. The light left behind from that time stopped scattering with this plasma, and so we can still see that light. And as the universe expanded, this light has been stretched from really short wavelengths into the microwave region, and that's what the South Pole telescope observes. So this radiation is all around us, everywhere, at all times. And what we're currently doing is scanning a patch of the sky, 1,500 square degrees of the sky at the South Pole, and just scanning up and down it to improve our signal to noise. So the current receiver in the South Pole telescope, which is the 3rd generation, came online in 2017. And since then, it's been just scanning the same part of the sky and improving the depth of our maps.
You go to the telescope once a day, and you're in the South Pole.
Yep.
That must be quite an experience each day, based on what the weather would be like down there. Like, I'm assuming there are processes and systems in place that you have to go through each time you go, okay, we're going to go to the telescope now. It's not just a matter of pop your shoes on and head down to the telescope.
No, it actually is.
It is literally just put your shoes on and head down.
No, you put your shoes on and layers and bunch of warm clothes. And I can tell you the weather right now.
Okay, that'd be good actually. So what's the time down there at the moment?
It's 9:05 a.m. It's completely arbitrary, but we choose to follow New Zealand time because McMurdo, which is the other US station, is the transit point is Christchurch, and so we just follow New Zealand time. The temperature right now is minus 61 C, and with wind chill, it's minus 86.
Oh my gosh. So how many layers do you have to wear to be able to go outside?
So usually a t-shirt, a fleece, then I wear another thin windproof jacket, and then we have these things called big reds, which are really heavy down feather jackets, and you wear insulated Carhartt pants, and you wear what we call bunny boots, so they're big white boots with an insulated layer of air, and you wear glove liners, and then you wear either mittens or bear paws, which go over the whole thing. Any exposed skin is in these conditions, especially with wind, will be frostbitten within minutes.
All right, so you got all your gear on, and you're going to go down to the telescope. You hop in a vehicle, a snow vehicle, and drive down there?
Vehicles don't work down here. Like there is there's I think two special, I guess, machines that work down here during the winter, but nothing else. It's too cold for everything else during the winter, so we just walk out there.
So you got to walk. So you put all that gear on and then just go for a 1K walk to a telescope.
Yep. It's actually amazing. Like in like good weather, you have the Milky Way and auroras out almost all the time. So sometimes it's tough to like do deep sky astrophotography because the auroras are getting in the way. But then but there are almost always some level of aurora activity. There might be like a couple of nights a year when it's completely dark, but we do have large spells of bad weather, so we can have high winds for 4 days to a week, and I think the highest wind that I've seen was like 25 to 30 knot winds, which is like 60 km/h winds. Yeah. There's a flag line out to the telescope, so flags every 2 or 3 meters, and you just walk. As long as you can see the next flag, you just walk out to the telescope. And sometimes when the high winds, you put on some good music and you feel like you're in a different world on a space station or something.
Oh my gosh.
Yeah. I think, so just on the astrophotography side of things, did you take your gear down there?
I did. So I brought 2 cameras, a bunch of lenses, and a star tracker.
So you've got the camera. So you don't have you haven't got a telescope down there. You've just got the star tracker.
No,
which is that thing there that I've got. The one that I've got in the background there. For the audio people, you have to go to YouTube and watch it on YouTube so you can see me pointing to my Star Adventurer.
I have the same one, a Star Adventurer.
Yeah. And how does the camera go in that cold weather?
Oh, it hates it. My older camera outside, which is a Sony A7S, will die within 1 or 2 minutes. The newer Sony camera will die within 10 minutes if it's not windy. But what we do down here is make insulated foam boxes which protect it from the wind. And if you want to do time lapses, if you're old school, you just put a hot water bottle full of like boiling water in there, and it keeps your camera going for a couple of hours.
Oh,
And
wow.
what people have been doing, what I've done recently, is put heaters and a powered system to keep it warm in there. And I think recently I just shot a time lapse for 50 hours, and it was heated, and it managed to keep going.
Much
I
easier.
have to go back to the Star Adventurer, and like I'm assuming, therefore, it's powered not through the batteries, that you've got a power supply running that, or you're running it off batteries.
The problem with all the electronics down here most often is that the batteries freeze and they just stop producing power. And and so camera sensors love to be cold, but if they're not powered, they're just dead. So what I do is like power everything through either external battery packs, which are then put in an insulated heated box to keep the batteries going. So like one setup that I have is I have 2 power banks. One powers the camera and the other powers a heater, which keeps both batteries warm. So yeah.
So what powers the Star Adventurer? That was my question. It's like, because mine's just got 4 AA batteries in there.
Oh, it has a USB, old school USB port, which you can power it through.
So yeah, that's what I was thinking. So you run it off a power bank then externally that you keep warm.
Yep.
Okay. Yeah.
Yep.
I was going to say, like, that makes sense now.
And I've had to replace all the cables which get cold, because even when it was minus 40 in the summer, in like less than a minute, all these plastic cables freeze and then they instantly shatter. So I've replaced all the cables with like cold proof Teflon coated cables.
I'm not going to complain about it being 2 degrees outside when I'm out the back now.
my sister still complains about it being like 16 degrees at home, and she's like, "Oh, it's so cold." I was like, "What are you talking about?"
I'm thinking I'm rugged up more for a very early morning in Melbourne than you seem to be at the South Pole. So.
Well, it's comfortable in here. I think it's like 15 to 18 degrees is what
Nice.
they maintain the building at.
But what's a typical day in the life for you at the South Pole?
It depends, but mostly the main thing is going out to the telescope once a day, scheduling observations, making sure everything looks good. If there are any problems with the processing of data, the initial processing of data that goes on down here, we have to work on that or communicate with the North to get it fixed. Other than that, I usually try and go out if the weather is good and shoot the auroras or the Milky Way, or at least on my walk out to the telescope, I'm lugging around a giant tripod and a camera in my jacket, and then pull it out and take a couple of pictures. The evenings usually have some activity. So they're activities organized by the community almost every day of the week, from watching TV shows in one of the lounges down here to sports. So there's a lot of sports going on. So we have very active volleyball, football, or they call it soccer down here. And there's basketball, and people are learning how to unicycle down here. I attempted it, but it's not for me. Yeah, so there's always stuff happening.
We've had some amazing things from your man. What's the most interesting thing you've been involved in relating to your work?
For work, it was probably being part of observing for the Event Horizon Telescope. So that's a collaboration of microwave radio telescopes around the world, which come together for a week every year to observe black holes. And it's very apt for your podcast because the Spaghettification podcast icon is a black hole.
Oh, yes.
And how you get sucked into a black hole and become a long string of spaghetti. And so we got to do that this year and talk to astronomers and coordinate with astronomers all around the world, set up a telescope in a very specific configuration. And it was long days, so like 16 to 18-hour days for a week. Wow. But it was amazing to be part of something so huge. Yeah, so that's definitely the most exciting work-related thing.
You've got your name on the paper, then that means.
I will eventually. The delay between working, like observing data, and actually producing anything meaningful is 5 years to a decade. Yep. Because at least a year before the data that we observed early this year makes it north, and then it has to be correlated with data from all other telescopes.
Still very cool. That's
yeah,
that's a nice thing to have on the resume. Actually sat up and watched the press release on that when they announced it with the new image of Sagittarius A. It was very cool.
We downloaded the news release, and we all watched it on Sunday in the galley at lunch, and it was fun. I saw Lisa Cooley on the press release. I was like, hey, I know someone.
Yeah.
Who got that?
With the Event Horizon Telescope, so you guys are obviously the most southern telescope. I don't think you can get more south than where you are. So yeah. What's like the furthest telescope in the collaboration from you? Because I'm guessing that would set your resolution, would be the sort of most distant points.
I think the most northern one is the Greenland telescope. So we have a bunch of ones in Chile and around the equator, and we also have the Greenland telescope and the South Pole telescope are the farthest from all points, and we basically form the longest baseline. So I talked about these pairs of telescopes, and every possible combination of pairs is called a baseline. And the addition of the South Pole telescope to the collaboration basically provided a bunch of really long baselines, which give you the really high resolution.
So you guys are like the furthest apart. So how many telescopes are in that interferometer all hooked up together?
I think there are, in principle, 11 telescopes, but I think at the peak, at any one given time, there might be 6 to 8 telescopes observing, depending on where you are in the sky. Because if you're looking at the southern target, some telescopes can see it, and we can't see above the celestial equator. So when they were observing M87, which was the first result from the Event Horizon Telescope collaboration, we can't even see that target. It's below the horizon for us. But when we're looking at Sag A star, the black hole at the center of a galaxy, it's high up in the sky. It's probably the highest up in the sky for us. And we get a continuous view of it 24/7. I think they design a schedule which kind of optimizes the time of all telescopes, because it's really valuable time. A lot of the time is dictated by ALMA's time. And so it's very optimized to say, how can we maximize the use of this time, and when telescopes come in and out of range for different targets. And so they planned it in like observing days, and the South Pole telescope only participated in like, I think, 5 observing days of like 7 or 8 observing days.
It must be an incredible challenge to just coordinate that many telescopes.
We're given a schedule which is if you're more than 2 seconds late to any target, you've lost that observation. So that's
Wow.
and we have, I guess, like in the telescope building, we have the most precise clock on the continent. So it's a maser, which
Yeah.
basically is an oscillating microwave laser, which provides accuracy to, I think we looked at it, it loses 1 second in a billion years or something like that. And that basically allows us to synchronize, it's allowing us to make measurements on a sub-wavelength timescale, which gives you the phase of the light that you're observing. And if you have the phase information of the light that you're observing, you can correlate it with other telescopes. So this clock is basically at the heart of everything, because if you couldn't precisely measure, because what the EHT is doing is, most interferometers do real-time correlation. So basically they have signal coming to all these dishes and cables routing it to the computer where they're comparing the signals in real time and making images. And we can't do that here. Firstly, because distances are so large, we have no internet connectivity, and the data rates are like 700 GB per second, which is just insane for the kind of satellite links we have down here. So we're doing delayed correlation of our data. So we record data with incredibly precise time information, and all telescopes do that. And that time information gives us the ability to measure phase on the light that we're observing, so that you can correlate it later.
That's very cool.
That's extremely cool. I didn't know any of that. Thank you, man.
Yeah, it's one of those things you just don't think about. You're like, oh yeah, you just, you're doing it live, but you can't, because like you say, you're all the way down there. It's so far away from everything. Being down there and so far away from everything, your lunar eclipse with an aurora in it, like that's very, very cool. What was it like being down at the South Pole to experience? Well, since you experienced both, what was it like being down there to experience both of those events?
Well, solar eclipse was the first one. It was like a month after I got here, and I set up 2 cameras, one on the telescope building and another pointing towards the telescope, and it was wild, actually. So like we were out there watching it, and you could see it was still bright outside, but I guess the hue of the light had changed to more violet purpley light, and you could definitely see like the thin crescent of the sun, and you could feel the temperature drop. And we could actually later look at our data, or like we have a weather station, and see the temperature just drop and come back up. And so that was wild. And then we had a lunar eclipse following that, and we had shit weather beforehand and shit weather after, and it was just perfectly clear during the eclipse, and it was amazing.
That's amazing.
And like it was clear, but we had 20 knots of sustained wind through the whole eclipse, so it was really cold. And we would go out there constantly, and like in the full moon, it's bright as day, or like we have not had day for months, so it's bright as day for us. So it's like you have bluish sky, you have a bright light in the sky, and then you see that slowly dim and the stars come out, and that is amazing. Over the course of like half an hour, you can start to see so many stars, and then the Milky Way, and then the Milky Way core, and then there are auroras. And it's like until halfway through the eclipse, we hadn't seen auroras. I'm like, man, maybe we're not going to see auroras. And then it just lit up the sky, and there was like a stream of auroras going across the sky, and it was intersecting with the Milky Way, so they're like making a cross in the sky, and it was incredible.
I love it. I just looked at that shot, and I'm just like, that's every astrophotographer's dream, to be in a place like that, to capture an image like that all in one go. So you get everything. You're getting the Milky Way, you're getting the aurora, you're getting the eclipse. It's just a very cool experience. I'm very jealous.
I don't know if you've seen the time lapse, but I almost prefer the time lapse to the
Oh, it's beautiful.
composite image, because you can see how the light changes and like how the stars emerge and the colors change. And
Yeah.
yeah, but it was pure magic, man.
Yeah.
Now we're up to the fun part that I don't think anyone's told you about.
I haven't.
No, you haven't? Oh, awesome. Cool. So we do this thing towards the end of the podcast, and it's called a spot quiz. And it's not about radio astronomy. What we do is we take the first letter of our guest's name, and we find a topic to ask 5 questions about. And so I chose for you artichokes. So we've got 5 questions on artichokes, and we get a very good laugh out of these sort of things. So we're going to test your knowledge on artichokes.
No, I know nothing about artichokes. So I'm eager to learn.
I'm glad. So the first question is, what Greek myth is the scientific name for artichoke Cynara cardansulus derived? So that's its scientific name, or as best as I can pronounce it. What Greek myth is it named after?
I have no idea. It must be something to do with like a monster or something like that. I actually have zero idea.
You got to have a guess. So Greek, going to think Greek myth. So
maybe like the Hydra or something, because the artichoke is like a freaky flower, fruit, vegetable. I don't know what it is, but it's got all these like layers and like things, and it's delicious. But like, yeah.
I like the idea where you're going with the Hydra, because it kind of has that scaly look to it.
Yeah.
But according to Greek mythology, the artichoke became known through the Greek god Zeus. As the story goes, Zeus spotted a beautiful girl named Cynara. While visiting his brother Poseidon, he instantly fell in love, made her a goddess, and took her back to Mount Olympus with him. However, she became lonesome and took secret trips to visit her family. And as soon as Zeus discovered that she was taking these trips, he got angry and kicked her off Mount Olympus and turned her into an artichoke.
That's a good one.
It's a good one, isn't it?
Yeah.
A poor lady who got turned into an artichoke.
All because she wanted to see her family back home.
So, my question is, the Castroville Artichoke Food and Wine Festival is an annual event attracting artichoke lovers everywhere. It even has its own artichoke queen named at each festival. Which famous Hollywood person was named Castroville Artichoke Queen in 1959?
Oh, guys.
Do you want a hint?
Nah.
We'll give you a hint. Hollywood.
Yes,
Hollywood. Famous Hollywood person.
Yeah, but I know nothing about Hollywood, especially
Female.
in 1950s.
Sang to the president.
Madonna?
No. Who was it, Steffi?
What?
It was actually Marilyn Monroe.
Oh, shit, I should have known that. I was like, it's an M name.
Well, Marilyn Monroe was named the official California Artichoke Queen in 1959. So this one's a little bit more scientific. The third question. How many artichokes can a single artichoke plant produce in a single season?
7.
That was very quick.
It's the right order of magnitude.
How close am I?
I'll let you have another guess that's a bit higher. Like more than double?
Let's say 30.
That was too many.
Don't be mean to him.
in between?
Okay, let's do 20, 15.
15. I like the answer 20 was a good one.
Okay.
A single artichoke plant can produce 20 artichokes a year.
I had no idea, so any guess was as good as any.
It's all right. I had no idea about any of these either when I was looking it up.
I was like, false confidence. 7.
I like that. It was like there was not even any like, oh, I'll have a think about this. It was just a straight out 7.
Yeah.
It's all a bit of fun, this. But we do have a leaderboard, and you're not on the leaderboard.
Oh, really?
Yeah, Dwayne knows a weird about donkeys.
Yeah, Dwayne's
Oh, really?
knowledge on donkeys was, yeah, that's not right. That's not right. How he just knew all that stuff.
He knows a lot about a lot of weird things.
He does know about a lot of things. Okay, my next question, Aman. What are artichokes and where do they come from?
I already showed my ignorance in this when I said, is it a fruit? Is it a flower? Is it a seed? So
one of those is correct.
I'm going to guess it's a flower.
Yes, very good. The artichoke is an unbloomed flower, part of the sunflower family from the Mediterranean and the Canary Islands.
There you go. We're on a point. He's on the board.
Yes.
Crowd goes
Finally on the board.
On the board. On the board. I'm trying to work out if any. We'll so far no one's got it. No one's got a 0, so that's a good thing.
Really?
But Dwayne's got the most. I think he had 3.5, and the average is about 2. So don't fret about this. You're not far off the average. All right. Now, before the 16th century, women were not allowed to eat artichokes. Why? What is it about artichokes that might mean that you can't eat that? Women weren't allowed to eat them. He's thinking. We need the thinking music. Do, 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 do,
do. Maybe it's because they're a scaly, weird-looking fruit. People had myths about like beauty and how it might change how you look. I have no idea.
That's actually
pretty
a really
close.
cool.
Pretty close.
Yeah, a really cool idea, and it was to do with a change, but it wasn't to do with looks. It was because they were considered to have aphrodisiac properties.
Oh,
so they didn't.
Okay.
They didn't want the women eating the artichokes in case they got a bit antsy. But after the 16th century, that changed. They were allowed to eat artichokes.
So were they like, oh, it's fine for you to have fun, or were like, that's a false idea?
I don't know. It's actually a good idea. I'm going to look that up now. I'm going to find out what was the reason for that. Was it because they just went, oh yeah, we'll let women have fun now, or was it because, oh no, it doesn't do what we thought it did? I'm tipping it's probably the second one.
Yeah, 16th century was still a while back.
Yes, it was. Well, there you go. You got 1 out of 5, so you didn't fail miserably. But you're not leading. Yeah. Dwayne's still leading.
That's fine.
It's all right. The first few people only got 2 and 1.5 or something like that. Anyway, that's the whole idea of it. It's just a bit of fun. Crazy stuff.
It was exciting. Fun. Yeah, it was interesting too.
Yeah, we all learned something new. So we now know more about artichokes. Aman, thank you very much for joining us on this podcast. It's been a fun little journey. I've learned a lot about the weather down in the South Pole there, and what it's like to try and do astrophotography in minus 61 degrees. And I don't think any astrophotographer should ever complain about the weather and their gear getting cold and I mean, no one's ever allowed to complain about that now. None at all. No one, not less down the South Pole. Minus 61 is not fun to work in. So thank you very much for sharing your stories. It's been great fun.
Very welcome.
It's been wonderful.
This has been really fun to chat with you both too.
Yay.
Different people who aren't the same people that you've seen every day down there for as long as you've been down there. Different places.
We're just coming up on midwinter, so we have another 5 months to go.
So is it one of those ones, before we close it out, is it one of those ones where it's like, oh my God, 5 months to go? Or is it, holy cow, I've only got 5 more months here? Like, is it a bit of both, or is it one or the other that's more taken over there?
I think it's more of the second. Like, it's not got tiring for me down here, and it's constantly amazing. So I'm glad it's not gone downhill.
Thank you again, Aman. That was really wonderful. And maybe we'll have to catch up with you when you get back to Melbourne.
Yes.
For sure.
Definite catch up.